Hello, everyone, and welcome to 1.4 Solving Systems of Equations B. So we started 1.4 during the last video, and in this section, the method is not new, but there are some special problems that we need to deal with. I'm actually going to go back and do 2 review examples because I think that they'll help you understand what's going to happen in our system of 3 equations in just a few minutes. So first, we're going to solve this system here. Hopefully you look at it right away and say, oh, if I multiply by 2, I can cancel something. So if this is A and this is B, I'm going to do 2A. I can get rid of those x's right away. 4x minus 6y is equal to 6. And then I write down B, negative 4x plus 6y is equal to negative 6. Now, my intention was just to cancel the x's, but it turns out that everything canceled. When this happens, it means something really special. So we're going to graph this line, and then I think you'll see. So subtracting 2x from both sides, I get negative 2x plus 3. Dividing by negative 3, I get 2/3 x minus 1. So when x is 0, y is negative 1. That's the y-intercept. And then it goes up 2 over 3, up 2 over 3. And then I go back 3 and down 2 because I need to draw all my points to make a really good line. Now this one, again, I'm going to do some steps without you. I think you can do it though. 6y is equal to 4x. I brought the 4x over, minus 6. Divide by 6. Notice I'm not showing that step anymore. Divide by 6 I can do in my head. 2/3 x minus 1. So look what we have here. We have the exact same line. Okay? In other words, if you have a line and you want to find out where it intersects, well, if they're the exact same line, they intersect everywhere. So I'm going to try and draw it in green right on top. I don't know if you can see it. They intersect everywhere. So it is possible that your Algebra 1 teacher might have said there are infinite solutions. And this is very, very true. But that is not an acceptable answer. Instead, I want to know a pattern for the answers, meaning the answers are only the points on this line. 0, negative 1 is a solution. 3, 1 is a solution. 6, 3 is a solution. These are solutions. 3, 1, 0, negative 1, negative 3, negative 3. All of these are solutions. So there are infinite solutions. I could do this all day long. But 0, 4, not a solution. So how can you describe to somebody what all the solutions are? The solutions are the point on the line y is equal to 2/3 x minus 1. But normally we express the answer as an ordered pair. Well, we can still do that. If you knew x, so for any x, what's the y value that's going to be on this line? 2/3 x minus 1. That's the pattern. The y is, right, 2/3 x minus 1. So if you know x, you have 2/3 x minus 1. A little tricky, but this concept, if you're like, oh, I don't quite get that, that's actually what we're going to spend the whole entire block on, okay? Writing our answer as an ordered pair, or in a few minutes an ordered triple, to say this will let somebody figure out what the solutions are. The second kind of problem we have today, very similar. Again, if you call this A and this B, and you multiply A by 2 to cancel those x's, 4x minus 6y is equal to 6. And then you write B, negative 4x plus 6y is equal to 6. Not quite everything cancels. So graphically, what must have happened that the lines didn't cancel? They can't be the same line. If they were the same line, then if you had a line and you subtracted the line, you would get 0. But we got 12. So let's graph it. So this one, negative 3y is equal to negative 2x plus 3. Y is equal to 2/3 x minus 1. Same line. Up 2 over 3. Up 2 over 3. There's my red line. Blue line. 6y is equal to 4x plus 6. Y is equal to 2/3 x plus 1. So this one, when x is 0, y is 1, its y-intercept is 0, 1. And it goes up 2 over 3, up 2 over 3. So these lines are parallel. Here's the little way you can remember. If you get a false equation, so 0 is not equal to 12, the lines are parallel. If you get a true equation, the lines coincide. That's the word for when two lines are on top of each other. Coincide. And my pen didn't work right, and it's an important word because you might not know how to spell it. Coincide. Okay? So while those two facts are true, notice I didn't box them. They're not the answer. The answer to this question is no solution. Because remember, when somebody says solve a system, they mean algebraically, it means tell me all the points that work for the top equation and the bottom equation. And the fact is that there's none. There's not a single XY combination that's going to fit in there and work for both of those equations. When you're solving a system of equations, what are you doing graphically? You're finding the point of intersection, and parallel lines will never intersect. So these are the two kind of problems that we're going to deal with today. Ones where there's no solution, and ones where there's an infinite number of solutions, and learning how to express that properly. So I went back and reviewed this with a system of 2 equations, but our goal today is to do it with a system of 3 equations. Remember that whenever you have an x and a y, that's going to make a line of some kind in the coordinate plane. But when you have an x, a y, and a z, it actually makes a whole plane. So instead of just drawing a line on your desk, it would be your whole desk. It forms a plane because it's 3-dimensional. So you have this line, but then you have z's going out in all directions, and it ends up creating this plane. Okay. So how could there be infinitely many solutions? Well, let's say you had 3 pieces of paper. They've tried to make them slightly different colors, which you can't see on your photocopy, but you can certainly see on this video. If you had 3 different pieces of paper and you sliced them, you could actually make them intersect and then fold in this special way. They would all be intersecting right along this line. That would be an example of infinite solutions. These 3 would be an example of no solution. If you had 3 pieces of paper and you made them parallel to each other. If you had 3 pieces of paper and 2 of them were parallel and another one intersected. Or if you made a configuration like this in a triangular form. These 2 lines, or these 2 planes intersect along this line. And these 2 planes intersect along this line. But all 3 planes don't intersect anywhere. Even up here, the intersection of these 2 planes is this line right there. So let's actually do a problem. For systems with an infinite number of solutions, you are required to express your answer as an ordered triple. Remember, if you just say, there are infinite solutions, I will only give you half the credit because you only really got me half the understanding. You know there's infinite solutions, but I need to know what they are. We are going to start this problem exactly the same way. So I'm going to go a little quickly for you in the beginning so as not to waste your time. Equations A, B, and C. A is my favorite because it's so easily manipulated. I'm going to do negative 5a, which would give me negative 5x minus 5y minus 5z is equal to negative 10. I'm going to put that with B, which gives me 5x plus 5y plus 5z is equal to it's already 3, don't have to multiply by anything. I get 0, 0, 0, negative 7. I go back, I think to myself, oh, I know that means something. What does it mean again? If you get a false equation, the lines, or in this case, the planes, are parallel, or they somehow don't intersect completely, there is no solution. So you are going to write no solution. If you would like, you may use this symbol. This symbol also means no solution. I know it looks like the number 0, but it's not. It's no solution. All right, let's do another one. We're going to label them A, B, and C. I think I can get rid of x pretty easily if I do negative 2a and b. If you want to do that on your own, negative 2, negative 2, negative 2, and negative 2. I have to really think hard to make sure I don't make a mistake. And then b, I'm just going to leave. I put those together, and I get an equation with just y's and z's. So if you understood what we were doing the other day, now I know I have to use c, and I have to get rid of x again. I have to have an equation with y's and z's so I can put these two together. This is going to make equation D, and this one I'm going to make a new equation E. So with C, I can very easily use C and negative A, which would be negative x minus 2y plus 7z is equal to plus 4. That gives me positive y minus 5z is equal to negative 7. Now I take D and E, and because I correctly solved both of them for y's and z's, I got rid of the x both times. I could have gotten rid of the y or the z, it doesn't matter. As long as you have the same two variables left, now I can put these together. So I'm going to do something a little tricky. I am going to use E. A lot of people think that you always need to multiply by something, and they would have multiplied E by 3. Instead, I'm going to do D divided by 3. It'll give me smaller numbers. Divide by 3 is negative 1. Divide by 3 is 5. And divide by 3 is 7. I put them together, and this time everything canceled. What does that mean? It means that there are infinite solutions. If you stop here, you're only getting half credit. This is not the answer. I need to know what kind of answers work. I need an example like 1, 3, 6 or 2, 4, negative 1. I want actual answers. There's infinite solutions, but what are they? And we can actually express that. Here's how. All right, so step 1, go back to equation E or D and solve for one of the two variables. Doesn't matter which one. So I look at this and I think E is definitely easier. Y is equal to, well, I guess I'll show the actual step. Y minus 5z is equal to negative 7. I look at that and I think, I'm picking this one because I can get the y all by itself easily. You always want to pick the equation where you can get y all by itself easily, or whatever variable. Step 2, put this in your ordered triple. Okay, now all answers must use that variable. Meaning, you're telling me that y is 5z minus 7. So I'm going to put 5z minus 7, oops, right there. Okay, that's what you decided. Y is 5z minus 7. So that's what's going to go there. And now z is my variable. All three parts are going to have to use z. Step 3, fill in the variable you're going to use. Which in this case, here, it's going to be z. To its spot in the ordered triple. So now, remember, from step 1, I picked one variable I could get easily. It was y, and I made y 5z minus 7. So that is still 5z minus 7. In this step, I'm filling in the variable I'm going to use, so z is my variable. I'm going to put that in its correct spot, which is here. I'm almost done. I know 2 of the 3 variables. Now think back to your homework from last night. When you knew 2 of the answers, how did you get the last one? I'm going to go up here just so instead of scrolling down so you can keep seeing it. So step 4 would be use the 2 you have so far and plug them into one of the originals to find the last variable. So notice I said one of the originals, it doesn't matter. I look back at my equation and I think to myself, which one is the easiest, A, B, or C? I don't know. I kind of like A. So I'm going to write down. So here in this example, I pick A. I think I was using capitals before, so I'm going to go ahead and erase that and switch that to a capital just to be consistent for you. So A says x plus 2y minus 7z is equal to negative 4. So I'm trying to find x. So if these had been numbers, like 7 and 8, you would have plugged 7 and 8 in for y and z, but they're not numbers. So what are you plugging in? 5z minus 7. You're plugging in what the 2 that you got so far. This is very new and different for you, and I recognize that. And what are you plugging in for z? Oh, z got to stay the same. But if they had been numbers, what would you have done? you would have gotten x all by itself. So still get x by itself. Get x, or whatever variable it is, by itself. So I'm going to have x plus 10z minus 14 minus 7z is equal to negative 4. X, I'm going to combine the z's in this step, and I'm going to add 14 to both sides in this step, because you're honors, and I think you can do more than one step at a time. And I get minus 3z plus 10. That is the last variable. Remember, it has to be in terms of z. Once you do that step 1, you got to stick with that variable. So x is 3z plus 10, y is 5z minus 7, and z gets to be z. Okay, from step 2, or rather step 3, fill in the variable you are going to use, which in our case was z, and just put it in its spot. It's the easy step. Okay, I do want you to do one extra thing for me. I want you to find one of the infinite answers. One of the infinite number of answers. So you tell me that there's infinite solutions, then you better be able to give me one. So how do I get one? You just pick an ordered triple. Start with z, because that's the easy one. So I'm going to make z 2. If z is 2, then y is 5 times 2 is 10. 10 minus 7 is 3. If z is 2, negative 3 times 2 is negative 6. Negative 6 plus 10 is 4. If I'm right, then these should work. This answer should work in all 3 equations. This answer should work in all 3 original equations. I'm going to try in equation B, just to show you. So equation B is 2 times 4 plus y plus z should be equal to 13. 8 plus 5 is equal to 13. Okay, you should feel really confident that you got it right, because you came up with an ordered triple and it worked. If you were really careful, you could try your ordered triple in A, B, and C, but this problem was already pretty long. So you can see why you're being given so much room on your paper to do this. So I'm going to do 2 more of these with you. If you would like to try them on your own, you're certainly welcome to. But I am going to do them for you. All right, so you'll see I wrote clear fractions first. So while this would be my equation A, for my equation B, I would multiply everything through by 2. That would clear the fraction. So my equation B is going to be 4x plus y minus 6z is equal to 0. That's going to be my equation B. In my equation C, I'm going to multiply this by 4, because 4 times 1 over 4 would just make 1. So my equation C is going to be negative 4x minus y minus 4z is equal to 0. I personally think that it is a huge advantage to work with 3 normal equations. Okay, just to do something different, I'm not going to get rid of x this time. I'm going to get rid of y. I see that b and c are going to combine quite nicely. b, 4x plus y minus 6z is equal to 0. C, negative 4x minus y minus 4z is equal to 0. I get 0, 0, negative 10z is equal to 0. I divide, but first of all, this is not of the type we've been doing. I did not get zeros all the way across. So you cannot say that there's infinite solutions. The only time you can say there's infinite solutions is when you actually get 0 and 0 and 0, or 2 is equal to 2, any kind of true equation. But this one actually, I'm getting to a rut when you're doing your homework and say, oh, they're all going to be this way. Z is equal to 0. 0 divided by 10, or negative 10, is 0. So now normally you also would have done A and one of the equations to also get rid of either x or y. But this one just worked out. You already know that y is 0, but or z is 0, but you still have to figure out the whole entire thing. So I'm going to actually use A, but I'm going to put in the 0 that I know. And now I'm going to pick C, because if I pick C, I can get rid of the y's again. So negative 4x minus y, but I might as well use the z is equal to 0 because I know it. Okay? So since z is 0, I'm going to use that. I go to do the problem, and I get 0 plus 0 is equal to 0. Hold on now. What's going on? I thought this one wasn't infinite solutions. Well, here's an interesting twist. Sometimes part of the equation has infinite solutions. In this case, x and y have an infinite number of combinations, but z is always 0. So you're still going to have to practice this infinite part right here. So let me just box the answer. The answer is definitely going to have y be 0. But since I got a true equation, that indicates that x and y are related somehow, but don't have actual answers. They're related somehow, but they don't have answers. So I need to make that relationship. So whenever this happens, you go back up to an equation with only two variables and you get one by itself. Which one are you able to get easiest by itself? The y. So I'm going to write y is equal to negative 4x. I know it was y last time. It's not always y, but that was the easiest for me to get all by itself. So I get y is equal to negative 4x. And then what do you do with that? You write that down. You put it in its spot. Y is negative 4x. And then you look at your answers and you say, all right, I've chosen my variable. So one of them gets to just be put in. So going back to your steps, we went back and we solved when we had an equation with just two variables. We found their relationship. Then I put that variable in my ordered triple. And now I'm on step 3. I'm going to fill in the variable that I've decided to use in its spot. So since I've decided on x, I get to put the x in its spot. So this one was a lot shorter because it did have a permanent z. All right, remember I want one ordered triple. So if x is 1, y is negative 4. That's one of them. If x is 8, y is negative 32, and z is still 0. If x is negative 3, y is 12, z is still 0. How long could I do this? All day long. There are an infinite number of solutions to this equation, but they all follow this pattern. And so I was able to give them a pattern. All right, let's do one more. No clearing fractions this time. I'm just going to label them A, B, and C. I like A. Look at A. All right, I think I'm going to get rid of Z this time. I'm just trying to make it different each time. So I'm going to actually do negative A. That would give me negative x minus y minus z is negative 2. And then I'm going to use B. Notice how I'm showing my work This is going to be really important to me because people do make mistakes on these problems and quizzes, and then having your work be all neat and organized lets me help find it for you. So the z's canceled like I wanted them to, and I have this equation. Now I have to use c. I don't care if you use a or b, but I have to use c. I can alter c. I can use negative c or whatever, but I'm just going to use c because it's easier for me to alter a or b in this case. Which one am I going to pick? I'm going to pick a again. A is definitely the easiest one, and I have to get rid of z because I want an equation with x's and y's just like I have over here on D. So in order to get rid of z, I'm going to multiply by -2. So -2x minus 2y minus 2z is equal to -4. That gives me -5x. Oh, the y's canceled. No y. Oh, that's because my z's, I didn't want -2. I wanted +2. The z's are already negative. So I just want +2a because he's already negative. I'm trying to get rid of the z's. So that gives me -x plus 4y is equal to -9. I'm going to call this equation E. So now I'm going to put D and E together. I don't need to do anything because the x's are going to cancel right away. X minus 4y is equal to 9. And I think, oh, look at that. There's a -x. And then I see this. Uh-oh. Also a 4y. And a -9. What does that give me? You knew it was going to be this, right? So this tells me there's infinite solutions. Step 1, go back to D or E and figure out which variable you can get alone the easiest. You can definitely get that x alone. X is 4y plus 9. That's step 1. Step 2, put that in your ordered triple. X is 4y plus 9. That's what you've decided. X is going to be 4y plus 9. If it had said x is equal to 8, you would have written an 8 there. X is 4y plus 9. Step 3, now that you've decided on y, fill in everything else with y's, which the only one you know is this one. And last, you're going to have to go back to one of the originals with what you know so far. I'm going to pick A again. I really like A. So A is x plus y plus z is equal to 2. I'm going to fill it in as 4y plus 9. Y is y. And z is what I'm going to solve for. So I want to leave it there temporarily. So I get 5y. And I'm going to move the 9 to the other side. Subtract 9 from both sides gives me -7. And now I can get the z alone. -5y minus 7. And now I can fill that in. -5y minus 7. You are required to show me one ordered triple that actually works. Start with y in this case. So let's just pick y is equal to 1. 1's easy. I don't actually pick 0 very often. You might think 0 is even easier because 0 doesn't give me a good sense of whether or not I did my answer right. Because even if I'd accidentally written 3y or 8y, a 0 times anything would have still been 0, so it doesn't tell me that it's right. But by putting in a 1, that makes this 13, which is a unique number, and if it works, then I know I did it right. And then -5 times 1 is -5, minus 7 is -12. So let's see if it works. Let's do it in A. 13 plus 1 minus 12 had better be 2. 14 minus 12 is 2. I feel totally excited about my answer. I feel very confident that this is the right answer because the ordered triple that I picked actually worked. Whew. Tough lesson, But you guys, it's been a few weeks now, and I can tell that you are a smart crowd. So so good luck with these. There is one left. It is the challenge problem. And you know what? When I look at your notes, I'm going to make that extra credit. You don't have to do it, okay? But it is hard. It's got some ugly fractions in it. So just in case you need a point somewhere, go ahead and do this one if you want to. You can work with a friend. Remember that there are 3 different answers. Somebody might get X all by itself and then have answers for this. Somebody else might have Y all by itself. And somebody else might have Z be the one that they solve for. And I'll have all 3 of those answers ready, so any one of them will work. All right. I hope you have a great rest of the day. Thanks for working hard in math.